Hello, hello. Um, in this video lecture, I shall explain about the implementation of the Bitonic merging that I have explained into the previous video. Here, in the last video, we have discussed about this particular sequence. This is a sample sequence having the values 3, 5, 8, 9 up to the original sequence up to the 0, which is basically a Bitonic sequence. Now into this Bitonic sequence, we have started comparing the values. We have divided the input into two equal halves, and such that we are comparing the values from the first element of the first half with the second element of the second half, and then we have started comparing the values. For example, 3 is compared with the 95, then 5 is compared with the 90, and so on. In this way, we have in this way we were able to divide the input into two halves, into the two parts, such that one part is having the value this much, and the other part is having the value 8 elements. Similarly, this 8 element sublist is again being divided into the 8 four elements uh, sublist, such that the second after the second Bitonic split, the first list is having the value 3580, while the second list is having the value 10, 12, 49, and so on. In this way, this whole process will continue. Now, this whole process now this is the logical implementation of the Bitonic merging. Now, if we want to implement this Bitonic merging onto the Bitonic merging network with the help of the comparators and the increasing comparators and the decreasing comparators, how it can be done, that I shall explain now. Now, before that, it should be recalled that the that the increasing comparators in which the value x and y is being given, gives the output x prime, which is having the minimum value, while y prime is having the maximum value, and the symbol for it is of this form. So here you can be able to observe uh, that uh, that as I explained into the outline of the Bitonic, into the um, into the uh, sorting network, that the inputs are being provided with the help of the wires. In the same way, the inputs are being provided. Actually, we used to provide the input into the form of the variables or the arrays, but here we are providing the values in the form of the wires, that the wire has the binary code as 0000 and the 0001, and so on. The values are being given. With respect to this 0000, the value 3 is being given, which is the first value of this particular series. Now, with respect to the second value of the series, which is the value 5, this value is being given at the triple zero one. Now, 0010, it is basically the zeroth value, first value, second value, third value, fourth value. So these values are being assigned in according to their binary notation towards the wire, and they are being assigned into the first column of the comparator. Now they are being assigned as an input towards the first column of the sorting network. So here you can be able to see that this particular that this whole thing is showing that how can we be able to derive the sorted output or the increasing order output from the Bitonic sequence, that that from an irregular output. That how can we be that how can we be able to generate a output if the input is the Bitonic sequence, such that we can be able to observe that from the value 3 up to the 20, it is monotonically increasing. Then from the 95 up to the 0, it is monotonically decreasing. So here, in order to compare these values, the value 3 is being compared with the value 95. The value 3 is being compared with the 95. Since in this way, this is the input x, and this is the input y with respect to the comparator at here. So it is the circle plus comparator notation at here, and circle plus comparator notation at here. So it is the x value and it is the y value which is being compared, just like you can be able to observe from this addition figure. So this 3 is being compared with the 95. Similarly, this value 5 is being compared with the 90. Similarly, this 8 is being compared with the 60, and so on. So in this way we are comparing. So in this way we are comparing into the first column with respect to the four splits. There are four different columns. So I can be able to say that the network has the that this Bitonic merging network is having the logarithm of n columns. So it is having the logarithm of n columns, that there are 1, 2, 3, and 4 columns are there. And in and into the and as we have discussed the outline of the sorting network, here at each after the each comparator um, after each of the after providing input to each of the comparators, whether increasing comparators or decreasing comparators, they used to generate the output, intermediate output. So with respect to this intermediate input and these sort of comparators, this intermediate output is being generated. Now again, this intermediate value is being given as an input towards the towards these set of computers, and as well as these set of computers, such that this intermediate output will be generated. Again again this intermediate output is being fed towards this particular intermediate um, uh, computers, such that this intermediate output will be generated. And finally, when this value will be applied towards at here, then this sorted output will be generated. Now, please observe that each column has n by 2 comparators, that the value 3 is being compared with the 95. Similarly, 5 is being compared with the 90. So when 3 is being compared with the 95, it is basically a one comparator, because you can be able to say that see that here in this figure, in a single comparator there are two circle positive signs. So here again 3 is being compared to the 95, so it is the comparator 1. Then when 5 is being compared to the 90, it is being done with respect to the comparator number 2. So when 8 is being compared with the 60, it is the comparator number 3. When 9 is being compared with the 40, it is the comparator number 4. So in this way 8 comparators are being used into the first column. Now with respect to now with after doing the first Bitonic split, again we are comparing 3 with the 10. So it is the first comparator. 5 is being compared with the 12, so it is the second comparator. 8 is being compared with the 14, so it is the third comparator. And 9 is being compared with the value 0. So it is the fourth comparator. So it is the fourth um, comparator. Similarly, 95 is being compared with the 35, so it is the fifth comparator. 90 is being compared with the 23, it is the sixth comparator. 60 is being compared with the 80, it is the seventh. And in total there are 8 comparators are being used. Similarly, after the second Bitonic split, again there are 8 comparators. 3 is being compared with the 8 into the first comparator. 5 is being compared with the 0 into the second comparator. And in this way, 8 comparators, first 1, 2, 3, 4, 5, 6, 7, and 8 comparators are being used. And into the fourth column, there is one first comparator, comparator 2, comparator 3, comparator 4. So in each of the step there are equal number of comparators. You can be able to recall from the previous diagrams, um, uh, the outline of the figure, that there are equal number of comparators into the each column. So here you can be able to observe that there are 8 comparators into the column 1, 8 comparators into the column 2, 8 comparators into the column 3, and 8 comparators into the column 4. Now each column has the n by 2 comparators, so there are 16 elements. So 16 by 2 is the 8 comparators are there. Now each column performs one step of the Bitonic merging. Now this whole method is known as Bitonic merging, and each splitting operation is known as Bitonic splitting, and with the help of this first split, the first step of the Bitonic merge has been performed. So here each column performs one step of the Bitonic merging each column. So here this step performs the one step of step one of the Bitonic merging. The step 2 is performing the second step of the Bitonic merging. The third step is performing the third step of the Bitonic merging, and the fourth column, the first column is implementing the first step of Bitonic merging. The second column is implementing the second step of Bitonic merging. The third column is implementing the third step of Bitonic merging. The fourth column is implementing the fourth step of Bitonic merging. So here the input of the network. So it should be noted that this sorting of the output, this sorting of the input cannot be performed with any arbitrary input. If the input if the input is already into the Bitonic sequence, then only we can be able to generate the output into this form. So the input of this network is a Bitonic sequence, and then we can be able to generate a sorted sequence. How how to convert an arbitrarily unordered sequence into the Bitonic sequence, that we shall see later. But here it should be observed that this is a Bitonic sequence, and which is to be converted into the sorted output. Now the Bitonic merging network on n inputs is denoted by this circle plus 16, that we can be able to summarize this whole thing into this particular acronym. That this the symbol for that since we are employing only the positive comparators, so this is circle positive sign is there, BM16. So we are working onto the 16 values. Now for generating the decreasing order output, we have to simply replace the positive signs with the negative values. We have to simply replace the positive signs with the negative values in this way, such that it will be denoted by the circle negative sign VMN, where n is the value 16. So if I will arrange the output into the decreasing order, then it will become circle negative BM16. Now, when we shall perform the sorting of the unordered output,